Hello, my name is Joy. Me with my teammate Shurida Binte Rashed are going to talk about longest palindromic subsequence. In this presentation, our main goal is to discuss what LPS is, how to solve it efficiently, see its pseudocodes, time complexities, and we will also try to see some uses and variations of this. The following are what the presentation contains. Now, what is a palindrome? Palindromes are sequences that are both same if read from forward and backward. Here, madam is a palindrome. But teach isn't a palindrome. What is a subsequence? Subsequence can be any sequence from a given string, but we have to maintain the order of those elements. Here are some examples to show what are subsequence and what are not. Now, from the given understanding, what is the longest palindromic subsequence? So if you want to find the LPS of this given string, then we'll have to find all the palindromic subsequences first. So if we find the palindromic subsequences here, then this 5 will be there. And we can see ABCBA is the largest one of all of them. So this is the LPS here. Now, how do we solve this problem? There are two methods to solve this problem. One is the brute force or the recursion solution. Another one is the dynamic programming solution. We will actually stick with the DP method as it is better and sophisticated way to solve this problem. First of all, let's consider this string, which will we try to find the LPS. Its LPS will be represented as L of O5. In LPS problem, there will always be two conditions. If the ith character and jth character are same, we add 2 and add L of I plus 1 and j of minus 1's value. Here is example to show how this works. If not same, we put the maximum of L of I, j minus 1 and L of I plus 1, j's value. Here is another example to show how this block works. In this DP method, the already done sum problems are saved, and that's why it's actually sophisticated. We'll take two pointers I and j, then we'll create a matrix with row and column of length of the string. At first, I and j will be covering only one character, so we'll not think like this lady here and put 1 in all the diagonal values, as they will always be covering one character. Now, I and j will be covering two characters, so we'll have the conditions, and first the I and j character are not same, so it will go to the else block. We'll find the maximum of the orange marked values and put that in the L of ij's position, which is marked as red here. Again, they go to the else block. Most of the time, the algorithm will go to the else block actually. Now, I and j are covering three characters. Again, we do what we are doing. I and j are not same, so else block. However, this time I and j both are representing B, so it will go to the if block, and we'll take the bottom left corner's value and add 2 with it. It's because BCB has a palindromic subsequence of 3. Then ij moves, and again it leads to the else block. Again it leads to the else block as they are not same. Now I and j are covering 4 characters. We do exactly the same, and again it's going to the else block. Now for 5 characters we again exactly do the same. Here we can see I and j both are A, so it will go to the if block, and we take the bottom left diagonal corners value and add 2 with it. It again goes to the else block as they are not same, and take the maximum of 3 of 1, which is 3. So Now we are in the last step where ing covers the whole string, which is the length of 6. It again goes to the else block, as I and j are representing different characters, and 5, and between 5 and 3, 5 is the maximum, so we put 5 in the red marked value. So we have done it. The longest palindromic subsequence for the given string is actually 5. The matrix's first row's last value will denote that. Some notes: we can find LPS for any I and j here. We are also not using the lower diagonal values. They remain empty. We also don't find the actual LPS string, but we find the LPS length using it. Here's the pseudocode for this solution. At first, we make a matrix or the DP array with 0 everywhere. Then we'll fill the diagonals with 1. Then we'll fill the rest of it using the DP method. And at last, we return the first row's last index, which is the LPS of the string. Thank you for listening to me. Now my teammate Shurida will continue with the presentation.
Thank you, Shaman, for your extremely clear and understandable explanation. Hello everyone, I'm Shurida Binte Rashed, ID 20101451, and I'll be the presenter for the remaining couple of minutes. The time complexity of brute force approach is big O of 2 to the power n, and its space complexity is big O of n. But in the DP approach, the complexity is big O of n squared. It is because we have to fill half of the matrix consists of n rows and n columns. Mainly it is n squared divided by 2, which ultimately becomes big O of n squared. And as we are using the 2D array, the space complexity is also big O of n squared. However, this space complexity can be reduced to big O of n. We need to make sure the array stores the same length as the longest palindromic subsequence. Now that we got the length of the LPS, how can we print or get the main LPS? For that, we will go back to our DP array. Here, we can see at the right corners 5, which denotes the LPS length is coming from its right. So we will just ignore it and go to its left value, which also is 5. But this time we can see that the 5 comes from the diagonal left bottom. So we will take the row or columns value in our main sequence like this. We will then go to the diagonal left bottom and find 3. This again comes from its diagonal left bottom. So we will take the row or columns value in our main sequence like this. Now we move to the diagonal left bottom and find the value 1. This one comes from no value, and in code it will be 0. So whatever we get 0, we will add one's row or columns value to our sequence like this and end our finding. This ABCBA is our LPS. However, implementing the code of this can be quite tricky. There is an easier way to find the main sequence. For that, we can use LCS or longest common subsequence algorithm. Here we can see that if we try to find common subsequence between a string and its inverse, we get 2 sequences, and the largest one is actually the LPS. For printing the LPS, firstly we need to inverse the given sequence and store it in another variable. Then perform the LCS with parameters of the given string. We will get the reverse version of the string. Lastly, after finding the LCS, we will print it, and that will be our desired LPS. This is the pseudocode. At first, we will implement the LCS function. Then in our LPS function, we will just call the LCS function with parameter string, its inverse string, string length, and the reverse string's length. We will return this, and this will return us the desired LPS. LPS and LCS are kind of similar, but only difference can be the LCS finds the sequence from 2 sections, whereas the LPS does it from 1 section. Now we will see an alternate approach to our problem, which is brute force or recursion solution. In brute force solution, we need to find all the possible palindromes, and after comparing them, we will get the longest one. But the drawback of this process is that it will take exponential amount of time, and the time complexity will be 2 to the power n. Here, taking the parameter I and j, I referring to the first index and j to the last one. If the match, we will add 2 and I will move one position forward and j will come one step back. However, if I is not equal to j, we need to find the maximum of either moving the last index one step backward or moving the first index one step ahead. Checking whichever is giving us the maximum, we'll take that. So if we apply the conditions, our taken string of recursive pattern will look something like this. And the tree shall continue onward. Now, if we look closely, we can see that there are overlapping subproblems. Here, we need to do the L1,4 twice. If we continue the recursive pattern, we will see more overlapping problems. So consequently, it will hamper the time complexity. Therefore, solving our problem with a DP will be more efficient, as the overlapping subproblems need not to be solved again and again. That's why its time complexity is big O of n squared. That was all from us. We appreciate your patience. Thank you very much.